All right, y'all. So 9.3 deals with exponential functions. Now they start out with us wanting us to evaluate the expression e. So this is a new constant, sort of like pi, okay? They use this in a lot of investment type problems, and I'll let them explain that to you if you got to take business calculus or something like that. We're just going to approximate this out to like 4 decimal places. So when you see the squiggly equals, that means we're approximating it. And y'all, let me show you on our calculator here. I'm going to share the calculator. So there's 2 places you can get the E on the calculator. To get the E by itself, right above the division, you see a little blue E. So if you hit the second button and the divide button, it'll bring E up. And if you hit enter, it'll give you its approximation. Now we round these out 4 decimal places in this section, okay? So rounding that out to 4 decimal places, I got my 2 point, and then the 4 decimal places will be 718. So since I'm looking at the 2 is in the place of the 4th decimal, I've got to look at the 5th decimal place to see what I want to keep that a 2 or round it up to a 3. So behind that 2 is an 8. So since that 8 is 5 or greater, we would round that up to a 3 so that we get 2.7183. Now, if I got to use the E with an exponent, on the left side, if you hit the blue button and then the LN button right by the 4 there, there's a blue E to the X. That'll bring the E up with the exponents. Okay. Now, the reason I'm showing you that one, because we're about to go into Math Lab, and I'll show you what these first 2 problems look like. So let me get into Math Lab. So notice this one wants me to round 4 decimal places, e to the 3rd. So that's one of those where I would use the e with the exponent by hitting the second LN. So y'all, let's go find e to the 3rd, and we're going to go 4 decimal places. So I hit second LN and got the e brought up. So now I put in my exponent of 3 and then enter. So e to the 3rd is approximately 20 point. So now let's see what my 4 decimal places. I got a 0, 8, 5. The 4th unit is a 5, but it's got a 3 behind it. So we'll leave that a 5. So that'll be 20.0855. All right, y'all. So here, all we do is we put in our, what do we get? 20.0855. Okay, so you round them off 4 decimal places and then go to the next one. Now, the next one's the same thing. It is an e to a negative 3.43. So we're going to round that out 4 decimal places. So let me go grab my calculator. So I'm going to hit second LN because that'll bring the e up with the exponent. And then I put in my negative 3.43. All right, so when I hit enter, I'm rounding it out 4 decimal places. So that'll be 0. So let's see what we got. 0.323. So the second 3 is in the 4th unit, but it's got an 8 behind it. So we'll round that 3 up to a 4. So we get 0.0323. 2, 4. Okay. So first two questions, that's all we're doing is practicing with the E on our calculator, okay? All right, so then we're going to start graphing these exponentials. So y'all, exponential functions come in the form of y equals a to the x. So a is what we call the base. And notice now the variable is the exponent. Okay. Now, if it's in this form, y equals some number raised to an exponent, those graphs, when we look at them, tend to rise left to right. So they're going to rise left to right. Now, if I got a fraction being raised to an exponent, something like a over b to the x. So now I got a fraction raised to an exponent. These graphs sort of do the opposite. And they will fall from the left to the right. Okay, so the fractions will decrease. The whole numbers will increase left to right. So there's a few properties about exponential functions. They all cross. So each graph crosses the point 0, 1. Yo, that's because remember, anything, no matter what this base is, if it's raised to the 0 exponent, anything to the 0 exponent equals 1. So that's why all these graphs, unless I shift them, will go through the point 0, 1 on the y-axis. All right, these graphs are continuous. So that means there's no places where they're undefined. They make a nice, smooth graph. And then the last thing they all do, notice, they're all sort of trying to hug that x-axis. So unless we move them, they make a horizontal asymptote. With the x-axis. That means they won't cross over the x-axis unless we shift the graphs doing that kind of stuff, okay? So I'm going to show you how to graph these on a calculator, and then they'll have you picking out a picture. So let's go look at our first one in MathLab. So these will start at number 3. So they want me to choose the graph of y equals 5 to the x. Now remember, we already said that the graphs of a whole number raised to an exponent sort of goes uphill left to right.
Is it A?
Oh, I'm probably pretty sure you're going to be right on that. And so let me show y'all. Let's go graph it. I'm going to go to y equals, and we had what, 5 to the x. So 5 exponent x. And I'm just going to graph it. Well, let me get my zoom back on this. Let me go to zoom and number 6 to get it back on a 10 by 10 here. All right, so you see my picture. And let me see, you said A, I believe it was, and it definitely looks like A. All right, 3 to the x. Well, what would y'all guess for 3 to the x, knowing that? Remember, it's still a whole number raised to an exponent.
A.
A again, there you go. Now remember, this is a fraction to an exponent. So instead of rising left to right, this one went downhill left to right. So what would y'all pick on that one?
B.
So let me see. There's only 2 that go downhill. Because remember, we said unless we move them around, they're not going to cross over that x-axis. And B's the only one that goes downhill. C's sort of crossed over the x-axis, so that and threw that one out, okay? But now if you wanted to graph that one, let's see, that was what? Y equals 1/2 to the x. So go to y equals. I'm going to clear that out. Now, if you want to make it look like a fraction, you can hit the alpha y equals. So I'm going to do my parentheses. Alpha y equals and enter. I'll put in my 1/2. Then I'm going to close these parentheses and put in my exponent of x. Now, y'all, so watch this. It definitely goes downhill to the left and right, but it does not cross over that x-axis, okay? All right, so you check that one. All right, so one more. This one will be a little trickier because they got the fraction in front of e to the x. So let's graph this one and see what it'll look like. So I'm going to go to the calculator. So that is 6/5 e to the x. So I'm going to go to y equals. So first, let me put in the 6/5. So it was alpha y equals to get my fraction. So I had 6 on top, 5 on bottom. Then I'm going to arrow right, and I'm going to use the E that's on the LN. So I'm going to hit second LN to pull up my E, and then I'll put in my X for the exponent. So now I got my 6/5 e to the x. I'm going to graph that and see what I get. So y'all look, since the e was in front of the x, it still looks like it's going uphill left to right. And it looks like it's crossing right at the 1 on the y-axis. So I'm going to go back and see which one of them 4 pictures. So it definitely looks like B here. Okay, the A sort of curved up too quick. So the B, we want it to cross right over at that 0, 1 on that, okay? Well, then we check that answer. All right, so now 7, we're going to start moving these graphs around. So let me give you the notes on that first. All right, so these will be transformations. Almost like the transformations we did in 7-2, where we moved our graphs left, right, up, down. We reflected over the x-axis. So these graphs do the same thing. So remember, we're looking at the exponential graphs. Y equals a to the x. So the first move would be vertical. So for a vertical shift, we would have y equals a to the x plus or minus b. So vertical is still true. We're adding or subtracting a number to the end of the function. If the b is positive, then it's going to go up. And if b is negative, then it's going to move down. Just like when we was in 7-2. You add a positive number, it went up. You subtract a number, it moved my graph down. So then the horizontal. Now, back in 7-2, the horizontal was inside the parentheses when I was attacking the x. Well, now our x's are exponents. So this would be y equals a to the x plus or minus c. Y'all notice the difference. Here, I had the function and then added the number. Here, I'm taking the function and adding the number or subtracting the number from the variable. So remember, when you attack the variable, if c is positive, well, when we added numbers to the x's inside the parentheses, when we added, it went left. So these are sort of backwards, just like in 7-2. If you add to the x, you're going to go left. If you subtract from the x, then you're going to go right. Okay? Now, the only other move in this section is a reflection over the y-axis. Remember, in 7-2, we reflected over the x-axis. So we're going to reflect over the y-axis. And to make a graph reflect over the y-axis, we'll have y equals a to the negative x. I changed the exponent to negative. It reflects my graph over the y-axis. And y'all, this last one is still the same. Reflection over the x-axis. So that'll still be the same. It'll be y equals negative a to the x. So if we change the sign of the exponent, we reflect over the y-axis. If we change the sign of the function, it'll reflect it over the x-axis. So y'all, keep this handy because we're about to do their examples, okay? Now, the real big thing you got to watch out for on these graphs is you got to tell it what base you're starting with. So let me go through these examples. So notice they're giving me f of x equals 2 to the x minus 5. So it says start with the graph of y equals blank to the x. That would be our base, which is a 2. So we put the 2 in the shaded box. But what we got to figure out, they're subtracting 5 from the variable. So is that going to move me left, right, up, or down? So that depends on whether I'm going to pick A, B, C, or D. Now, I will say that's going to be a horizontal move because we're attacking the exponent. So we said on horizontal, if that C is negative, which that's a negative 5, it's going to move me to the right. So you got to come down here and choose B. Start with the graph of y equals 2 to the x, and then we're going to shift it 5 units right. So to make you check that before we got to draw it, okay? Now we got to draw it. So I'm going to click to enlarge the graph. Now remember, the exponential graphs went uphill left to right. Well, we're going to go on the second row and pick the one that says exponential tool. And then we're just going to click anywhere on the graph. It always starts them right in the center. Now we said we went right 5. So we're going to take our horizontal, move that right to 5. So it moves my graph. Now, y'all, the biggest thing you got to watch out for on this so that you don't miss these is look in the bottom left of that box I just pulled up. It says base. By default, it's got the little E in there. We need to go in there and change that to the base of our problem, which is that 2. Once you put in the base, do your moves, you can then save it and check your answer. All right, now this one wants me to graph it first. Now, I know I'm starting with a base of 4. But what is that plus 5 going to do to me? So since that 5 is being added to the end of the function, you're looking at a vertical move. It's either going to go up or down.
Up.
So we said if it was positive, it's going to move up. So y'all, let's click to enlarge our graph. We're going to grab the exponential tool, click on the graph. We said that would go up 5. So that'd be a vertical shift, go to 5. And then come down here and change that base from an E to a 4. So the base is always the number in front of that exponent, okay? All right, so if you notice, it moved that graph up for us. So then we check our answer and move on. Oh, now they want to know the moves. Okay, so the graph of 4 to the x plus 5 is a basic exponential function. Y equals 4 to the x. So you come down and grab the one that's got the x like an exponent. And then here we did what? We shifted up 5 units. So this one you had to graph first and then pick the moves. All right, y'all, so let me show you this one. This one's a tricky one. F of x equals 3 to the 2 minus x plus 1. So on this one, your base is 3 no matter what. That 2 is going to go left or right. Since that's a positive 2, it's going to move it left. The x being negative is going to reflect you over the y-axis. So they just got it out of order, but it could be negative x plus 2 if you wanted to put them in order. And then at the end, that plus 1 vertical was going to move us up 1. So this one, we actually got to graph first. So let me show you how to do that. I'm going to grab the exponential tool, click on the graph. So the first 2, where I had the 2 minus x, that 2 being positive is going to move me left 2 horizontal. The negative x is going to reflect us over the y-axis. And then at the end, the plus 1 is going to move us up 1. Now remember, come down here. So this one's already got my base at 3, so I'm good. So I would save that. Check the answer. Then it's going to come in and make us do our moves. So we need the one that said left 2 units reflected across the y-axis. Well, they all got left 2 units. So it looks like A and C got reflected across the y-axis. but then A has down 1 unit and C had up 1 unit. We went up 1 unit, so we would pick C. So y'all, that's the trick on these, is just keeping that chart handy and figuring out where these numbers are. Now look at this one. F of x equals 3 minus 2 to the negative x. I'm going to share my pad so I can show you what I would do to that. So on this one, they got it sort of out of order. This one to me would be like negative 2 to the negative x plus 3. There it is, moving the number to the front on this one. But once you get it in order, now you can see the moves. Okay. You got that negative there, a negative in front of the exponent, and then this 3 at the end. So this 3, I will say, will move me up 3, okay? So let's go look at Math Lab and see what they're doing to us. So they want us to figure out the moves. So the exponent reflecting across the y-axis. The negative in front of the 2 is going to reflect it across the x-axis. Well, y'all, there's only one that's got both them moves. A is only doing the y-axis. C only did the x-axis. We need both, so it's got to be B. Now, the base would be the 2. Remember, the 2 is in front of the exponent. And then since we moved the 3 to the end, we can see that it is definitely going to go up 3. So the 2 negatives did both of these axes, okay? So you would check that answer. Now they'll make us graph it. So we're going to click to enlarge. Grab our exponential, click anywhere. All right, so we said first we're going to reflect across the y-axis because of the exponent. We're going to reflect across the x-axis because of the number in front being negative, the negative 2. And then we said we went up 3, so that would be vertical up 3. Now remember, change that base. I got an E there. I need to change it to a 2. You don't have to worry about the negative because we done took care of the negative with our reflections, okay? All right, you save that. Check your answer. All righty, so one more and then we'll get into a nice little formula. All right, y'all, so they're giving me 2 to the x plus 5 minus 3. So let's see what y'all would put in here. Y'all are going to start with the graph of y equals blank to the x. What's going in the first box?
Is it 2?
So it's going to be a 2. Now, it says shift it blank 5 units. Well, that 5 is being added to the variable in the exponent. So is that going to shift me right, left, up, or down?
Left?
All right, it's going to go left 5. Good job. And then shift it blank 3 units. So that'll be either left, down, right, or up.
Is it down?
So that'll be down. Good job. All right, so let's see. We check that answer. All right, so now we just got to graph it. So click your graph, grab your exponential tool, click on the graph. Let me see what all moves we did. You went left 5, so that'd be horizontal to -5. You went down 3, so vertical to -3. Also, my base, remember to change the base from an E to the 2. And I really think that's why they make you put the base in the problem so that you'll remember to change the base when you get there, okay? All right, so then you save that, check your answer, and move on. All righty, let me write this info down and then we'll play with this one. So $55,000 invested at 4.5% interest compounded quarterly. So they want me to find the function for which the investment grows after T years. So that means they want us to come up with a formula and then find the amount of money in the account at 0, 4, 5, and 10 years. All righty, y'all. So let me get my paper ready and I'm gonna go show you a formula real quick, and then we'll come back and play with that. So this is the formula we're using for these investments. So A of T equals P times parentheses 1 plus R divided by N, those parentheses, all raised to the N times T. So A of T, this means the amount in the account. So that's the amount in the account after T years. So basically the years is the variable for this, okay? P right here. P is your starting principal. Or the amount that you're starting with, okay? All right, then we got the R over the N. R is the interest rate. Now remember, the interest rate, when we plug it into the formula, has to be in decimal form. Okay? N right here. The N is the number of compounds per year. So they'll do things like annually. Annually would be once a year. Semi-annually, that would be twice a year. What else they got? Quarterly. Quarterly would be 4 times a year. They might do monthly. Well, monthly would be what? 12 times a year. And then they might do daily. Daily is 365 days a year, okay? So they might use them kind of numbers on your N here. So that's whenever they add the interest to your payments, okay? Now the only last thing is the T. T is the time in years. Okay, so we're gonna plug into this and come up with a formula. Because remember, the first thing they wanted me to do, they said suppose $55,000 is invested at 4.5% interest compounded quarterly So the first thing they wanted us to do, find the function for the amount to which the investment grows after T years. So they basically want me to figure this out, put all my stuff in, and come up with a formula for it, okay? So we will start out, our A of T is going to equal, well, I need my principal or my starting amount. Well, y'all, they gave that to us right here. They said 55,000 is invested. So that'll be our 55,000, our P. Then it's parentheses, 1 plus R over N. So now I got to figure out my R. So y'all, 4.5% is the same as 4.5%. So turn the half into a decimal. If you got anything else, turn that into a decimal, okay? Now, to turn percent into a decimal, you got to move the decimal left 2 units. So I'm going to move my decimal left 2 units, which means on this one, I need to add a 0 here. So that 4.5% is really 0.045. So that's going to go where the R is in my formula, 0.045. Now, N is the number of compounds per year. They said it was compounded quarterly. So what did we say quarterly would be? And y'all remember, you just got to figure out how many quarters are in a year. Oh, y'all, so remember, quarterly means 4 times, okay? Then you close the parentheses, and then we got NT, which will be N is still 4 times T, we don't know. Now, the only thing we got to do is simplify inside the parentheses. So A of T will equal 55,000 times parentheses. I'm going to ask my calculator what that equals. So I'm going to share my calculator. So it looks like the part I had in parentheses was 1 plus 0.045 divided by 4. So that was inside the parentheses. So let's see what that'll give us. So that gives me 1.01125. All right, so let me go back to the pad. So I changed that with the 1.01125, and then I still got my 4 times t as my exponent. This is what we're going to put in MathLab, okay? So let me go to MathLab and put that in. All right, so they give me the A of T already, so I'm going to put in my 55,000. Then I had parentheses 1.01125, close parentheses, and then for my exponent, that was 4t. Okay, y'all, you got to simplify the parentheses or they mark this one wrong for you, okay? Now it says, find the amount the money in the account at t equals 0, 4, 5, and 10 years. So let me continue. And they say round to the nearest dollar. So y'all, let me show y'all an easy way to do this one, because we got graphing calculators, right? Okay, no problem. So the graphing calculator, I'm going to go to my calculator. Now by hand, I would put a 0 in for the t, see what that gives me, a 4 for the t. So I'll show you how to do it by hand. But let me show you on the calculator. I'm going to go to y equals and clear that out. And I'm going to put in my equation, 55,000 parentheses 1.01125, close the parentheses. My exponent will be 4x. Remember, when you graph it, the variable has to be an x, okay? Now, I've got my graph in there, what I want to graph, and I don't even care what the graph looks like. I'm going to go to the table by hitting second graph. And I'm going to get down here. I'm going to start my table at that 0 up here. So when x is 0 or t is 0, look at that. I got $55,000. Well, that makes sense. If I invest $55,000 and no time has passed, I got $55,000. Now look, let me go down to 4 years would be x equals 4. At 4 years, I am at 65,781. They wanted to know about 5 years. Well, that's next. At 5 years, I'm at 68,791. And then finally, they said 10 years. So if I come over here and go to 10, that amount is 86,041. Now, do you notice this? If you look right below that, you see where it's got y1 equals 86,040.7275965. That's the decimal approximation. But since they wanted me to go to nearest dollars, that's why I'm using my table, okay? All right, so what we would do, we would go punch those in. Now, y'all, let me show you this. If you don't like to do the graphing, you can do them by hand, but you got to do it 4 times. You would start with your 55,000, parentheses, 1.01125, close parentheses, and then your exponent would be 4 times 0 for the first one. So remember on that one, we got 55,000. If you hit enter, you get 55,000. You can do it like that every time and just change the t every time, and you'll get these amounts, okay?
I have a question.
Okay, I hear you.
So when I do that in my calculator, I don't get the same table as you do. And I've checked it multiple times. Like I've got y equals 55,000 parentheses 1.01125 in parentheses. And then 4x.
Okay, so when you go to table, what's it looking like?
So when I go to 0, I get the same 0 as you.
Uh-huh.
Like 5, I don't get the same 5 as you. Or 4.
So you're not getting 65,781.
No, I get 65,780. And if I click on it, it doesn't look like it rounds up.
Oh,
Wait, yes, it does. Can it be 65,780.8 and still round up? Can that 0 still round up?
mm-hmm.
So the
Yeah.
calculator just isn't rounding it up?
So let me think a second here on that. What is your table set? Go to second window. And what's your table starting at?
4.
And what's it going by?
0.5, I think.
So that triangle table saying 0.5,
Yes, sir.
change that to a 1.
Okay.
So you're starting at 4, we're going to change it by 1. So now let's go back to the second graph in our table. And let me go up. Now, what are you showing on 4 now?
It still says 65,780. It's still not rounding up by itself. I mean, if I click on the square thingy, I can round it up myself.
Yeah. Only other thing I could think of, let's click mode.
Okay.
And is yours highlighting the float?
No. It's highlighting normal.
Oh, go right under that and see where mine's floating.
Yes, sir.
Make that float black by
Black.
clicking. Click on it.
Okay.
Now we're going to quit that. So second mode to quit.
Okay.
Now second graph to get that table back up.
It still won't round up.
Well, that's puzzling me.
Yeah, I know it. I'll
Um,
round it up myself.
okay, yeah, that's just really puzzling me. Why? Uh, oh, let me look at something here. Yeah, I'll have to play with that, but I'm going to figure it out before next class. How about that?
Okay. And I have one more question.
Okay.
Sorry.
Uh-huh.
Okay. So I'm working on number 12 with you, and I've got the same problem you do on the top half. And I did the work and I put your answer in and it's wrong.
On A,
Yes, sir.
all right, what'd you put in that blank?
I put 55,000 parentheses 1.01125 in parentheses to 4T.
Okay, so yours is 55,000, just like mine.
Oh, no, it's not. Mine's 86.
So see what your amount is. That might be the only thing
Okay.
you got to change.
Yeah, I think I didn't look at yours. I
Mhm.
couldn't see that 55 as well.
Yeah.
Thank
But if
you.
it's 4.5% compounded quarterly, everything else will be the same.
Yes, sir. Yes, sir.
And then y'all here, well, I would put in what I get, my 4 amounts, my 55,000. And it makes you check each one of these and put each one in. At 4 years, I had 65,781. At 5 years, I had 68,791. And y'all at 10, I had 86,041. Now, on that calculator, are you using an app or you got a physical calculator?
I have a physical one and an app, but I use the app for some of this complicated stuff because my calculator gets grumpy and it doesn't do what it's told to do. So
That sounds good. All right, let's see, y'all. Here's our so this would be a type of problem that you'll see using that formula, okay? So let's see. On Melissa's 6th birthday, she gets a $6,000 CD, 5% interest, compounded quarterly. So what they want to know, if the CD matures on her 13th birthday, how much money will be available? So I got my information wrote down, so let's go play with this one. Now this one, notice it says round to the nearest cent. When they say round to the nearest cent, they want 2 decimal places, like 25 cents or 34 or something like that, okay? So let's go play with this one. Now we're using the same formula. The A of t will equal to P times 1 plus R divided by N raised to the NT. Now, we're actually going to come up with an amount on this, how much she'll have available on that 13th birthday. So let's see what we're putting in. P, my starting amount. Well, y'all, they gave us that. What would y'all put in for your starting amount?
6,000.
All right, it's going to bring in my 6,000. And then it's 1 plus R. So R is 5%. What would 5% be in decimal form? And y'all remember, all y'all doing, y'all moving that left twice. So if you don't see a decimal, it's after the 5. So you're going to move it left twice. Add a 0. So that's going to be 0.05. So 5% is 0.05. 6% would be 0.06, and so on, okay? So that's going to be 0.05. Compounded quarterly. Well, we said quarterly was 4 times. So you got a 4 here, but remember, you also got the 4 up here times the t. Oh, y'all, how long is the t? She got it on her 6th birthday. It matures on her 13th birthday. So the time that passed would be the 13 minus 6, which would give us 7 years. So you're going to put in your 7 years there. Now remember, I'm going to round this off 2 decimal places. And this one, I'm just going to punch in on my calculator. So let me clear everything off here and over here. So we had our 6,000 parentheses 1 plus 0.05 divided by 4, close parentheses, and then the exponent will be 4 times 7. So see that 1 plus that 0.05 divided by 4, it's taking your interest and dividing it by how many times it gets compounded a year. Okay. Now that 4 times 7 is saying this is 4 compounds a year times 7 years. Okay, so that's how that sort of works out. So we got to hit enter, and we're going to round it 2 decimal places. So y'all, that'd be 8495 point. So let's see, 95. After the 5 is a 3, so we're going to keep that a 5. So I get $8,495.95. So you would go to Math Lab and punch that in, 8495.95. Okay, once you got all that in, check your answer and be done. So y'all, that's all you got tonight. Play with the E, estimate it out 4 decimal places. Cause tomorrow, when we got to our next class, I mean Wednesday, we're going to be doing a lot of estimating, so they're wanting you all to get good at being able to estimate stuff out 4 decimal places. Okay. And we will start getting into what we call logarithms. So if you remember the inverse stuff we was talking about, how the radicals were inverses of the exponents and vice versa. Well, the logarithms are going to be the inverses of these exponential graphs, okay? So we will play with logarithms on our next class. All right, let me think. I don't think there was any support for these 2 assignments this week. Nope, it's just 9.3 college algebra and then 9.4